Today I'll talk about stoichiometry and chemical equations. Now here is one example. Analyze the following problem involving dolomite. A sample here the problem. A sample of dolomite is analyzed to have the following composition: 60% calcium carbonate and 40% magnesium carbonate. Now question number 1, how many kilograms of calcium oxide can be obtained from 3 tons of dolomite? 3 tons mean 3000 kg. Now question number 2 is how many kilograms of carbon dioxide can be released per kilogram of dolomite? Now question number 3, how many kilograms of dolomites are required to produce 1 ton of lime, that is the mixture of calcium oxide and magnesium oxide. Now here are the two chemical equations. So one is that calcium carbonate decomposes and produce 1 mole of calcium oxide and carbon dioxide. Magnesium carbonate also decompose, that will produce magnesium oxide and carbon dioxide. Now here we have two equations. Now from these two equations, what insight we'll get? Now when we'll get any chemical equation, so first we have to check whether the equations are balanced or not. If not, first job is to balance the equation. Now here you can see that equations are balanced. So here 1, 1 and 1 means calcium is 1, here calcium is 1. Oxygen is 3, so here 1 oxygen, here 2 oxygen, 3, and carbon is 1. Okay, so similarly here also 1 magnesium, 1 carbon, here 1 carbon and 3 oxygen. Now insight from the chemical equations. So here are the insights. The first one is the reactants and products involved in the decomposition reactions. So here second one, the stoichiometric relationship between the reactants and products. Now because the third insight, for every mole of calcium carbonate that decomposes, that will produce 1 mole of calcium oxide and 1 mole of carbon dioxide. Now next one, for every mole of magnesium carbonate that decomposes, that will produce 1 mole of magnesium oxide and 1 mole of carbon dioxide. And last one, these reactions demonstrate the conservation of mass, where the total mass of reactants equal to the total mass of products. So these are the insight we got from the chemical equations or chemical reactions. Now we have to solve question number 1, 2 and 3. Now question number 1. Question number 1, we have to calculate calcium oxide from calcium carbonate. Now molar mass of calcium carbonate, that is 100 gram per mole. So calcium molecular weight is actually 40, carbon is 12, and oxygen 16. So now here if you calculate, so 1 calcium, then 1 carbon and 3 oxygen atom. So 3 into 16 plus 12 plus 40. So that will be 100. So molar mass of calcium carbonate is 100 gram. So molar mass of calcium oxide, so that is 56. So 40 plus 16. Now 3 tons means 3000 kg. So calcium carbonate in dolomites, so 60% of 3000 kg. So that is 1800 kg of calcium carbonate present in the dolomite. Now what will be the moles of calcium carbonate? So now from here we know the molar mass 100 gram per mole. So now we have to convert 1800 kg to gram. So 1800 into 1000 by 100 gram per mole. So from here we got that 18000 mole. So moles of calcium carbonate present in the dolomite, so that is 18000 mole. Now we know the the chemical reaction. So calcium carbonate decomposes, so that will produce calcium oxide plus carbon dioxide. So 1 mole of calcium carbonate produced 1 mole of calcium oxide and 1 mole of carbon dioxide. So now here that number of moles of calcium carbonate present in the dolomite is 1800 mole. So that will produce same amount of mole of calcium oxide. So because that calcium carbonate and calcium oxide ratio is 1:1. So now moles of calcium oxide is 1800 mole. Now molecular mass we know. So mass of calcium oxide will be 1800 into 56 gram per mole. So that is 1,008,000 gram. So now from this gram to kg we have to divide with 1000. So that is mass of calcium oxide in kg is 1008 kg. So next, calculate the carbon dioxide release per kilogram of dolomite. So molar mass of carbon dioxide, so that is 44 because carbon 12 and oxygen 16 into 2. So that is 44 gram per mole. Now carbon dioxide from calcium carbonate. Now here, so calcium carbonate and carbon dioxide ratio is 1:1. So that in dolomite 1800 moles of calcium carbonate present. So same amount of same mole that carbon dioxide will produce. So that carbon dioxide will produce from calcium carbonate is 1800 mole, and if we multiply it with 44 gram per mole, so that will be that amount of carbon dioxide actually produced from calcium carbonate. So that is 72900 gram. So now if I convert gram to kg, so that will be 792 kg. Now moles of magnesium carbonate. So now we got that 1800 kg of CaCO3. Rest amount will be magnesium. So magnesium carbonate. So that will be MgCO3. So that will be 3000 kg. So that will be the mixture of calcium carbonate and magnesium carbonate. So that will be 3000 kg. Now here, so moles of magnesium carbonate, that will be 1200 kg of magnesium carbonate into 1000. So we have to convert kg to gram divided by 84. 84 is the molecular weight of, or molar mass of magnesium carbonate. So that will give 14285.71 mole. Now if you see the reaction, so magnesium carbonate, that will decompose and that will produce magnesium oxide plus CO2. So 1 mole and 1 mole. So now 14285.71 mole magnesium carbonate is present in the dolomite. So now, so as that ratio of magnesium carbonate and carbon dioxide, 1:1. So that if that magnesium carbonate decompose, same amount will carbon dioxide will produce. Means 1 mole magnesium carbonate, that will produce 1 mole of carbon dioxide. So the total number of mole present is 14285.71 mole. So same amount of carbon dioxide will produce. So carbon dioxide from the magnesium carbonate, so that is 14285.71. Now if you multiplied the molecular mass or molar mass, so that will produce 628971.2 gram. So that if we convert that gram to kg, so that will be 628.97 kg. Now total carbon dioxide, so that is 792 is coming from the calcium carbonate and 628.97 is coming from magnesium carbonate. So total will be 1420.97 kg. Now carbon dioxide per kilogram of dolomite, so we have 3000 kg dolomite, so divided by 3000, so total amount is 1420.97 kg divided by 3000 kg, so that will be 0.474 kg per kg. Means carbon dioxide produced per kilogram of dolomite is 0.474 kg. Now question number 3, calculate the dolomite needed for 1 ton of lime. So you know the lime is the mixture of calcium oxide and magnesium oxide. So now here that calcium oxide produce 1008 kg. Now we have to calculate how much magnesium oxide is actually produced from that magnesium carbonate. So now moles of that magnesium oxide, that will same amount, means you know the equation. So CO3 Mg, so So that will produce MgO plus CO2. So 1 mole of magnesium carbonate decomposes, that will produce 1 mole of magnesium oxide. So total moles of magnesium carbonate present is 14285. So same amount magnesium oxide will produced. So moles of magnesium oxide is 14285.71 mole, because the ratio is 1:1. So mass of magnesium oxide will be multiplied with that molecular weight or molar mass of magnesium oxide. So that will be 14285.71 into that molar mass. So that will give that 571,428.57 gram. So now if we convert gram to kg, so that will be 571.43 kg. Now total lime will be 1008 kg from calcium carbonate, that is actually calcium oxide. Another is magnesium oxide, so that is 571.43. So total will be 1579.43 kg. So that will coming from 3000 kg of dolomite. Now if we need 1 ton of lime, means 1000 kg of lime, so how much dolomite is required? So if we need 1000 kg lime, so that will be 3000 into 1000 divided by 1579.43. So now here that 1000 is there. Now here that is actually divided by that 1579.43 divided by 3000, that will give actually 0.526478. So if we do the calculation, we will get that 1899.32 kg. So now that 1 ton, if we need 1 ton of lime, so we required 1899.32 kg of dolomite. That's it. Thank you.